Okay, so today's warm up, it says create a table for the parent function for a quadratic. So guys, let's go ahead and create a table for the quadratic. That's x squared. So I'm just going to plug in -2, -1, 0, 1, and 2. What's -2 squared? 4. -1 squared? 0 squared is 0, 1, 4. So I'm going to go ahead and graph the parent function. So -2, 4 is here. -1, 1, 0, 1, 1, 2, 4. Okay, so this is the quadratic parent function. Now, we're also going to create a table for the inverse. Okay, so guys, let's create the inverses table. What do I do to create the inverse? Yes, so we're going to flip x and y. So the y values will now be the x values. And guys, just for fun, let's give the inverse algebraically. This is the original. I'm going to switch x and y and solve. What do I do to both sides? Yep, so I'm going to square root. So guys, this is the square root. 1. It'll be plus or minus. Okay, because notice we have both positive and negative values in here. Okay, so guys, let's go ahead and graph our points. 4, -2 is right here. 1, -1. Okay, next point, 1, -1 is there. 0, 0, 1, 1, and 4, 2. So this is the inverse. Notice, guys, inverses are always a reflection across the diagonal. This point is looking in the mirror at this point. This point is looking in the mirror at this point. It's reflection across the diagonal. Okay, so those are the inverses. The question of the day. The question is the inverse of the quadratic parent function a function? Let's talk about it. I'm going to do the vertical line test. When I do vertical lines on the inverse, it touches more than once. It touches in 2 places. That means it is not a function. Let's look at the table of the inverse. Do you guys see how 4 is both equal to -2 and +2? And how 1 is equal to both -1 and +1? That is not real life. Okay? You can't be 2 places at one time. X can't be 4 can't be -2 and a +2. You can't be at Target and Walmart at the same time. Okay? So this is not a function. It does not work in real life. Okay? If you translate the table to a graph, you can look at the vertical line test. 4 is paired with both +2 and a -2. Okay, so that is not a function. What I'm going to write here is, let me clean this up a bit. What I'm going to write for the answer to the warm-up is no, because each x value does not have one unique y value. Some students like to say no, because here's another reason. The x's repeat, meaning 4 goes to -2, and then you have 4 again, but it's going to +2. Okay? All right. Let's talk about inverses. Not all functions have inverses. Those who do are called invertible. Invertible. And we can use the horizontal line test to determine if a function is going to be invertible or not. Okay? So let's go back to our warm-up problem. Guys, this quadratic is not invertible. You cannot invert it. The reason why is because if you do, this is no longer a function. Okay? So this is not invertible. The quadratic is not invertible. We cannot find the inverse because when we do find the inverse, it's not a function. Okay? So let's use the horizontal test. When I draw a horizontal line, it touches in two places. So this is not invertible. Is this invertible? Yes, it's invertible. What about this one? Yes. What about this one? No, it touches more than once. So this one is not invertible. Okay, guys, let's graph another function. Before we graph the parent function, now I'm going to graph this one. So guys, look, they graphed it for you. This is the parent function moved down 2 spaces. So normally it looks like this, but then they moved it down 2 spaces. Now it's here. Okay, does everyone understand that this is the graph? Okay, so the inverse would look something like this. And this is not a function. We can't do that. So what we're going to do in order to be able to get the inverse is I'm going to get rid of this part. Now when I invert it, it'll look something like this, or no. If I get rid of this side, let me make a table. This point right here is 0, -2. This point here is 1, -1. This point here is 2, 2. When I invert it, it will be -2, -1, 2, 0, 1, 2. So let me graph it for you. That's here, here, and here. So this is what the inverse looks like. So guys, what I did was I just got rid of this part of the graph. Now we can invert it. It's now a function. The inverse is a function. It passes the vertical line test. So guys, let's go ahead and do that here. Let's go ahead and make a table and graph the right side of this function. Notice, guys, this is the same equation. They're saying the x values are greater than or equal to 0. So let's go ahead and make a table. We're going to plug in values that are equal to 0 or bigger than 0. So I'll put in 0, 1, 2, and 3. If I plug in 0 here, what's 0 squared minus 2? 1 squared minus 2. 2 squared minus 2. 3 squared minus 2. 7. Okay, so let's go ahead and graph it. 0, -2 is here. 1, -1 is there. 2, 2 is there. 3, 7 is up here. So this is what your graph looks like. Notice, guys, it's just the right side of this one that we did here. It's just the right side of the graph. We're only doing the positive side. So guys, let's answer the domain questions. What's the domain of what I just drew? Everything is bigger than or equal to 0. What is the range? Yep, the very bottom is at -2, and everything is above that. So y is greater than or equal to -2. You could also write it like this, 0 to infinity, or you can write -2 to infinity. Okay, now guys, I have the inverse. Let's give the inverse equation. So let's go ahead and do some algebra. The inverse equation, we're going to switch x and y, so it'll be x equals y squared minus 2. What do I do first? Add 2. So we'll have x plus 2 equals y squared. And guys, I'm gonna square root both sides. And it'll be the positive. We're gonna choose the positive side. So the equation is x plus square root of x plus 2. All right, I'm gonna go ahead and graph this. I'm just gonna invert my table. So I'll just switch the table and graph it here. So negative 2, 0 is here. Negative 1, 1, 2, 2, 7, 3. That is the inverse. All right, let's go ahead. Let's answer the question for the domain of what I just graphed. So here's the left side. So what can you say about the domain? Yep, x is greater than or equal to negative 2. Okay, here is the bottom. Where's the bottom? 0, so that's y is greater than or equal to 0. Let me point out something. Do you guys notice how this just switched? Okay, just when you do inverses, x's and y's switch, domain and ranges switch. All right, let's do this side. Now, what do they say about the domain? It's less than or equal to 0. So let's make our table. I want values less than or equal to 0. So how about we do negative 3, negative 2, negative 1, 0. These are numbers less than or equal to 0. Okay, so guys, let's go ahead and plug this in. What is negative 3 squared minus 2? 7. Negative 2 squared minus 2. 2. Negative 1 squared minus 2. And this is negative 2. All right, let's go ahead and graph it. I'm going to graph it here. Negative 3, 7 is up here. Negative 2, 2. Negative 1, 1. 0, negative 2. All right, that's this side. And let me just go ahead and graph the inverse. No, let's answer the question. What's the domain of what I just drew? Exactly, x is less than or equal to 0. Here's the very bottom. What's the range? Yep, greater than or equal to negative 2. Everything is above that negative 2. Okay, now let's talk about the inverse. What's the equation for the inverse? We wrote it down here, but this time it's going to be the negative side. So you're going to put negative square root of x plus 2. And you'll see why when we graph it. Okay, let's go ahead and switch over the table. So the inverse will be 7, 2, negative 1, negative 2. So I switch the table. Let's go ahead and graph the inverse. 7, negative 3 is here. 2, negative 2. Negative 1, negative 1. Negative 2, 0. This is the inverse. Okay, what's the domain? Here's the left side. Yep, greater than or equal to negative 2. It's the same as the range. They just switch. And what's the inverse? Yep, here's the very top at 0. Everything is below it. So y is less than or equal to 0, which is basically what this was. Domain and range switch for inverses. Okay, let me point out something for you. Whenever, do you guys see how this is the bottom and this is the top? So that's why we have the positive equation for this one and the negative equation for this one. Okay. All right. Okay, you said you're stuck on the second one. Can you read it to me? Okay, so let's make a table. Let's plug in a 0. What's the square root of 0?
0.
Plus 4. Let's plug in a 4. What's the square root of 4? Plus 4 is 6. What's the square root of 9? Plus 4 is 7. Oh, we can also plug in a 1. What's the square root of 1? Plus 4 is 5. Okay, so if you graph this, 0, 4 is here. 1, 5 is here. 1, 2, 3, 4, 6 is here. And 9 is up there somewhere. Okay, and then you do the inverse, right? Okay, so let's talk about the domain and range just for the original one. What's the domain? Here's the left side. Where is that at? 0. So everything has to be bigger than or equal to 0. And the range, here's the bottom. Yep, greater than or equal to 4. Okay, now let's talk about the inverse. Inverse, you just switch the table. So your inverse will be 4, 5, 6, 7, 0, 1, 4, 9. So that's here. 5, 1 is here. 6, 4 is about here. It'll look like that. That's what the inverse looks like. And your domain, you just switch these. So it'll be x is greater than or equal to 4. Your range will be y is greater than or equal to 0. Good job, guys. So you should have found it algebraically, the inverse. So what you do is you switch x and y. So it'll look like this. And then subtract 3, yeah?
Yeah.
And you get x minus 3 equals the square root of y. And we square both sides. This is where I see a lot of mistakes. You square the whole side. You need parentheses. So that means the inverse is x minus 3 squared. Now, this is your answer. This is the inverse. Now, it says restrict its domain if necessary. So guys, let me just draw you a picture. If I were to graph this over here, this is the square root function. The square root function looks like this. And it was moved up 3 spaces. So now it's here. Thumbs up if that part makes sense. Okay, now let's graph this inverse. What is the transformation of the inverse? It went right 3? Okay, perfect. Normally the parent function looks like this, but this went to the right 3, so now it's here. Do those look like inverses of each other? It's supposed to reflect across this diagonal. It doesn't look like that, does it? No. Here's what will make it look like that, though. Just keep the right side of it. Now, do they look like mirror images? Okay, so what we did is we just kept the graph where it was bigger than 3. So your domain needs to be x is greater than or equal to 3. This is what the domain needs to be. Now, to figure that out without having to draw a picture, just think about what the range for this is. The original, it went up 3, so that means your range is y is greater than or equal to 3. Well, then that means that's going to be the domain of the inverse. Okay? Because if you just graph this, this is a U shape. We don't want the whole U, we just want one side of it. So we have to restrict the domain whenever you have a quadratic. Okay? All right. You guys try the rest in that section. Okay, on your own, find the inverse algebraically, and then come look up here and see if you did it correctly. Okay, this is the answer. Now, let's think about how we restrict the domain. This is the original. Can you guys tell me what the transformation is for this square root one? It's right 4. So the original graph moved right 4. So that means it looks like this. It moved to the right 4. Now let me graph this inverse. I'll inverse it. I'll put it in purple. This, what happened here? It went up 4. So a rough sketch is it looks like this. Does this look like a mirror image? So what do I need to get rid of? I need to get rid of this negative side. So what is my new domain? Yes, the new domain is x is greater than or equal to 0. Now, a quick way to think of this, since you guys don't have a graph on your paper, I just gave you a graph so you can have a visual, okay? But guys, look at the original function. What is the range of my original one down here? What's the range? Uh-oh. Yep, the range here is y is greater than or equal to 0. That means your domain will also be greater than 0. Because for inverses, you just switch the domain and range. So if you know that this didn't move up or down, this original did not go up or down, you know that the range is y is greater than or equal to 0. That means your domain has to match. The inverse's domain has to match that. Okay? All right, so you guys can do the rest of those. I just want to show you compositions again. We did compositions yesterday. Okay? So we're going to prove if these are inverses of each other. So I'm going to write this one nice and big, x squared plus 8. And instead of writing that x, I'm going to replace it with the function. I'm going to put this inside. Okay, do y'all see what cancels? What cancels? Yep, square root cancels out with the squared. I'm left with x minus 8 plus 8. And then these cancel, so I'm left with x. So it worked one way. Let's make sure it works the other way. I'm going to write the other function, x minus 8. That's this one down here. I'm going to erase this x and put the other function inside. I'm going to put this inside. X squared plus 8. What cancels out? Yep, 8 minus 8, that cancels out. I'm left with the square root x squared. What cancels? Square root and the squared, I'm left with x. So are these inverses? Yeah. Yes, we proved it using composition of functions. So for this first example, yes, f and g are inverses of each other. Because when you plug one inside the other, you get x. You plug the other one inside the other, you get x.